AJ here. I'm going to start some video series which is going to help you aspirants who are preparing for IIT JAM 2021. So share these videos to your friends. It's going to be completely free of cost and this is going to be very helpful for you. So in this first video I'm going to start with quantum mechanics and some very fundamental concepts which are very important in IIT JAM. So start. First of all, we need to know that Stephen-Boltzmann law, which says that intensity of radiation is proportional to 4th power of temperature. The intensity is, what is intensity? Intensity is energy per unit time per unit area, and power is energy per unit time. So quantum mechanics starts from where classical mechanics have failed to explain the black body spectrum and how energy actually discontinuous. Classical mechanics earlier explained that energy should be continuous, but quantum mechanically some difficulties arise to explain the spectrum of the radiation of black body. So Max Planck start some quantum hypothesis. From this classic quantum mechanics has started. So earlier classical, these are all classical theories, Lorentz displacement law and Stephen-Boltzmann law. These are all classical theories. They try to explain this classically, so they failed. So black body is a body which absorbs 100% of radiation which you emitted to it. Okay, its absorption coefficient is 100% and its reflection coefficient is 0. Its transmission coefficient is also 0. There is no perfect black body in nature, but some nearly perfect black bodies exist, like Ferris black body, platinum black and lamp black. Okay, this is the black body spectrum which this scientists earlier tried to explain through classical theories. When this displacement law is said that lambda is inversely proportional to temperature. When displacement law successfully explained this small part of radiation, but not able to explain the higher part of the spectrum. So, and this is the sigma, which Stephen-Boltzmann constant, and this is the Lorentz constant. So these two formulas are very important for your preparation. Okay, and relation between volume and temperature of a black body. This is the important relation. You can remember that. Okay, so this is the Maxwell-Boltzmann distribution law. Okay, this explains the distribution of the curves classically. Okay, and average energy of Planck oscillator, Max Planck successfully able to explain the whole part of the spectrum by his quantum mechanical hypothesis. According to his hypothesis, the average energy of a oscillator, he explained that and black body has some quantum mechanical harmonic oscillators which radiate and absorbs radiation by oscillating like a LHO, like a quantum harmonic oscillators. Okay, this is the very important formula, and this is I am trying to give you very brief picture how he explained that LHO. These are consist of small LHO, and they absorb and radiate by oscillating like this. And he explained that energy is quantized, is integer values, is new, n is new. Energy is quantized according to him. He able to explain everything very clearly, and it's very successful. And energy density of radiation in Planck's theory, E lambda d lambda is 5 by lambda to the power 4, and you can put that average energy formula like here, is nu e to the power is nu by kT minus 1. This is very important, and you can also remember this is also very important formula. The entropy of a black body, sometimes it comes exams, 4 by 3 sigma T cube, directly proportional to third power of temperature. Okay, wave nature of matter. Louis de Broglie explained this very clearly. This is the de Broglie formula. This is the h by p. P is the momentum. H is the Planck constant. You earlier seen that here. This is the Planck constant. So de Broglie wavelength is going to be very important. In relativistic condition, we need to add relativistic correction. This is the value of gamma here. Okay, in when particle is moving with relativistic speed almost equal to the speed of light, then we need to use this formula. Okay, don't use wrong formula in exam, so remember this. Okay, when particle is moving at very low speed, not in relativistic particle, then we need to use a different formula. We need to use this formula. Okay, kinetic energy we can define like this: p square by twice m. By putting the value, we can get this very important formula. Remember this, and we get this very important formula by putting the value of momentum here in this de Broglie formula, de Broglie wavelength. And another very important thing you need to remember, understand, the thermal neutrons. You probably studied in thermodynamics. The kinetic energy is the kinetic energy in 3 dimensions. Okay, 3 by 2 kVt is kV is the Boltzmann constant. Okay, we can use this directly here in de Broglie wavelength. We can get this here. Sometimes asked in exams that wavelength of thermal neutrons, then you need to use this formula. Okay, remember this. And okay, this is stopping potential. This is the stopping potential required to stop the electron EV. Okay, we can use this in de Broglie wavelength, and we get this and it is also very important. So we have come to a very important concept here. Okay, and from here almost quantum mechanics, real quantum mechanics starts. Phase velocity and group velocity. Okay, phase velocity is the velocity of single infinite wave. Therefore wave exists minus infinity to plus infinity. It's completely, its momentum is perfectly defined, but its position is not unmeasurable or undefined here according to uncertainty principle. So this is the phase velocity. Phase velocity is unacceptable because it's going from minus infinity to plus infinity. So we in quantum mechanics we use group velocity. Its velocity is the velocity of the combination of many wave combination of waves, and we get a group of waves like this. It is normalized in a certain position, so we can define this in a certain position, so therefore it is acceptable. Okay, and this is the formula of phase velocity, omega by k, and we also write E by p. So this is the group velocity formula, d omega by dk and E dE by dp. You need to remember this. This is going to be very useful in your exam. Okay, and remember one important thing: the wavelength of photon is greater than wavelength of electron. You can understand from this concept here. And momentum of electron is more than momentum of photon. Okay, so this all for today. Thank you for watching, and more videos are coming up. So follow me on Twitter, follow me on Telegram on IIT JAM 2021. I am going to give you very important concepts and formulas. So share this with your friends, and this is going to be very absolutely helpful for all of you. So thank you for watching.